Please. Okay. Thank you all. I'm part of Nanovia, that is an American company based in California. We opened the Italian office this year in Turin and take care of the European part. Today I will present our new system, that is a Tribometer. The new Tribometer is, I want to stress more part of the instrument, and we present some new, some first test we perform with our instrument. So we focus on the problem, we present the instrument, and the first two tests we take care and a little bit of conclusion. So who we are? We are producer of instrument, mainly. We have a lot of experience in developing instrument, basically for 3D reconstruction of the surface and roughness analysis, but also for indentation testing from the nanoscale to the macro scale. That takes care about hardness, about elastic modulus, character refractiveness, and things like this, and then the Tribometer that takes care about wearing, rate, and friction. We have the pleasure to work with thousands of different materials every year, and we do also third-party testing here in Italy and the USA. So we start to develop also solutions, customized solution for your need on testing, and we take care about the evolution. We want to produce innovative testing in order to let people understand the new material behaviors. So the friction can be a problem or a solution. If you have a brake and want to brake with your car, it's a solution, but mainly can be also a problem, and is strongly connected with fatigue on the surface. And friction has problem in industry and also related with metal fatigue. It worth nearly 1% of the internal load product. So in a lot of situation, we want to understand the behavior of our materials. So now are available a lot of different kind of testing in the tribological world. It takes us about testing in different temperature, in different linear rotating motion, corrosive, but there are some kind of tests that are not taken care now, but they are the one with a superimposing oscillation force. So when you have the force that occurs for your fatigue and want to stress the material also with a superimposed oscillating force. So this is why we start to develop a new system that takes care about this kind of testing needs. And we propose the new T2000. Why this kind of instrument is new for three main reasons. For the technique by which we apply the load, that is the pneumatic technique. Right now there are no thermometers that apply force with pneumatic actuator, plus an electromagnetic one actuator that works, that's an electromagnetic motor that works applying a superimposed force, oscillating one. And we have this double load, so we have the main load, pneumatic, the oscillating one, electromagnetic, that we can work up to 150 Hz. And we can add some accessories integrated in the system for 3D total reconstruction of the wearing track, nanotribology, temperature control, and all the things you want to understand your material behavior. So right now we have two different kind of system. The dead load traditional instrument are based on dead load simply applied on the sample, and in this case the friction is evaluated from deflection of the main arm that apply the load. So, and the other instrument is active load with standard motor, and since everything is very hard, you need dump the undesired vibration with a spring, mainly. So in the first case you have no control on the vibration that occurs. In the other case you don't take care about the vibration and you have not so perfect control on the load cell about the load that you want to apply. So our solution is to use a pneumatic main load that, think about the car that uses the pneumatic damping vibration system. Is natural damping for undesired vibration, but permit us to use a load controller in axis to take care of to monitor the load and apply a very precise load with a pneumatic load. And then we had an electromagnetic stage, and this electromagnetic stage can apply plus minus 20 Newton up to 150 Hertz, and it is an electromagnetic because we have zero friction in this case, and we have we do not have the vibration, and we have a very fast response that can let us to apply this fast up to 150 Hertz. So we have a direct load cell in axis for understanding the load that we apply, and we take care about the friction. We monitor the friction in two ways, with load cell direct measurement of friction, and also by torque variation of the motor. That can be another solution for taking care of the friction. So this is a 3D reconstruction of our instrument, in which we can see this part in where the sample is taken, and here we apply the load, and we can see, we can talk about this deeply during lunch or after. And for example, this is the accessory for the superimposed fork with the electromagnetic stage. We can add accessories for taking care of temperature, corrosion, liquid stress, and a linear confocal 3D system that after the test everything goes in front, and under the 3D reconstruction you can have information about the wearing directly with a precise measurement of the material that is weared by the test. So these are the first test we take care, is a wear resistant coating of 300 microns, and under the STM G99, that is a pin on disc test with precise norm, and we did a test in comparison with the standard dead load thermometer. So the main fact is that in regarding the standard test, we have less noise, and we have more or less the same behavior. But if we look at the surface and the fatigue that occurs, we can see that we have a more smooth response of the surface, and also if we perform a 3D reconstruction, we can see that since there are no undesired vibration during the test, all the tracks are calculating wearing tracks are of the same shape. Instead of standard dead load thermometer, when with the vibration are not taking care, you have in different position different behavior of the materials, and so you have a more accurate result on your test. Then we perform two tests with the dual load. So in this case, in black, we can see on copper sample, the basic sample, on the same kind of test, we have 0 Newton vibration superimposed and 5 Newton vibration superimposed. So if we look at the 5 Newton, we have a plateau area in which simply wearing occurs. Then we have the production of third party that are inside our wearing tracks and start lower the friction, and then we occur several fatigue. And if we apply 5 Newton, we can see that the friction coefficients start to rise higher, and we have much higher fatigue, and the wearing volume is maybe 2 times more than in the case of no other vibration. This can be very interesting because we can see that in some point, also if the copper is quite is appropriate material, we can see that there are some areas that are more stressed by the test, and in the case of superimposed 5 Newton oscillation, also if the oscillation period is not the same of the frequency of the motor space, and so these are mainly due to the material properties or non-isotropic material properties, and we can see the difference in behavior, and we can image to use this kind of test in a case in which, for example, in airplane, when we have a superimposed vibration due to the whole system that occurs during the life of the material. And this is another test. In this case is a coating, thin coating, and we can see under 0 vibration the same plateau, and then severe fatigue occurs when we reach the substrate, and in this case under 5 Newton and 10 Newtons the behavior is the same. So we can understand that without superimposed vibration we have one kind of behavior in the material. Then if we have a vibration, the behavior is similar, also if the final result can be different, but we can clearly see a different behavior with vibration, no vibration, that until now it was not possible to see with this kind of test. And these are the result with the 3D reconstruction. Totally, we can see that in respect the surface, the wear and track is much lower when we have a lot of when we add an oscillation force on this. So this is why we developed this kind of system, because of new testing need, because of the new materials and of the new use of materials. So we have an innovative design, a new dual load system that led us to be more accurate in respect to the standard testing machine that are now present, and so we show you the first 2 set of tests we did, and I want to thank you for your attention. And we have a laboratory also in Italy, and so we are happy to help you in your study, both in working together and with instruments. So, thank you.